Multivariable calculus, we're in section 14.1, and now we're going to look at a function of two variables. And just as we saw before, you could have a surface here. What we can do to really help begin to see what such an item, what such a function could look like, is to look at level curves, and we see this in mapping in topography, where you might be able to say when you're at a certain altitude, a mountain range has a certain shape and so forth. That's honestly very, very similar to what we're seeing here. So let's just say that we have a surface, and z is equal to some constant. We can find out what our domain really would look like for that one particular z value, and that could be very, very helpful. So let's take a look right here. F of x, y, that's our z, is equal to 100 minus x squared minus y squared. They want us to plot the level curves when k equals 0 and when k equals 51, 75, and then 100. So let's just get started right here. What if k equals 0? Well, that's like letting z equal 0, and we'd have 0 equals 100 minus x squared minus y squared. If we add x squared and y squared over here, you could see very quickly we have a circle, and that circle would have a radius of 10. So I'm going to come over here and just say that with a center of 0, 0 also, obviously. We could say, well, if we were to graph this thing out, what we're seeing is at a z value of 0, this is what our surface would look like. Likewise, there are many other possible z values or k values. We could say, well, what if k equaled 51? Well, again, we're letting that function, that z right here, equal 51, and we're going to see what we get. So we have 51 is equal to 100 minus x squared minus y squared. I'm going to add an x squared y squared to both sides. I'm also going to subtract a 51 from both sides. And 100 minus 51 is 49. So I'd have a circle, this time centered at 0, 0 like before, but going out to 7 for a radius. So we could very quickly get this thing graphed out, and you can see here's a circle, and it's looking just a little bit smaller. And by the way, this would be when k equaled 0. This right here would be when k equaled 51. You'd say, well, what about k equaling 75? Well, when k is equal to 75, we have 75 equals 100 minus x squared minus y squared. I'm going to add x squared plus y squared to both sides and subtract 75. I think you can see quickly your r this time is going to be a 5. So as we get this thing going right here, what are we really seeing? We're seeing that as we're going higher and higher with our z values, these circles are getting smaller, aren't they? And this would be where we'd say k equals 75. What about k equals 100? Well, at k equals 100, we have 100 equals 100 minus x squared minus y squared. We're going to add an x squared plus y squared to both sides, subtract 100. This is a degenerate circle. In other words, your radius is 0. You're right here at the middle there. So, that's what you'd get. One single point when z is up at 100. Wow, that's in other words saying, hey, at elevation 100, that would just be that one point. That would be the highest point on that surface, wouldn't it? So as we continue to look this out. We'll say k equals negative 21. We can do that off to the side also. Negative 21 for our z. Here we get 100 minus x squared minus y squared. Add our x squared plus y squared. Add a 21. Well, you've got a circle, but this time you're going to go out to a radius of 11. So we can go just, one additional step. And you can see what's happening. So, this would be when k equaled negative 21. So that's what a level curve is. It's like a little sneak peek. Obviously, it can be difficult to draw this in 3D at times. And this is going to allow us to have an idea as to when z is a particular value, what a little slice would look like, so to speak, if we were to slice it off at that particular z value. So we've got all these circles, and it looks like as we get up to the top, it gets to be rather small. All right, so we looked at level curves, but we can also have a level surface. Just as you could have an x comma y plugged into a function, you could also have a function based on 3 variables, a function of 3 variables, or you plug in an ordered triple. Now, what begs the question, this can be mind-blowing. Kids would say, well, what would that look like if we tried to graph it? Because let's be honest, you would have like another variable. Instead of calling that z, we could call it w. You could say we'd need a w-axis if we tried to graph that surface, or that function, I should say. And that's mind-blowing. But what we can do, more or less, is say, look, we could make level surfaces. We could let w equal some specific value. So describe the level surfaces. Maybe one of the easiest k values, like let's just set k right here. Set k equal to 0. You can think, well, what would that look like? Well, if we squared both sides, we'd have this. And this is a sphere, isn't it? But it's going to be a degenerate sphere. Centered at 0, 0, 0. We could say, what if k equaled 1? Well, we'd have a 1 right here. Here's x squared plus y squared plus z squared. Square both sides, and wow, you've got this right here. This is the equation of a sphere with a radius of 1, and you're centered at 0, 0, 0. So, wow, it looks like we're dealing with these spheres. It's at least allowing us to have an idea as to, get an idea of what could happen with this function. We could say, what's our x, y, and z looking like when w, or in this case, saying k equal to our function, is a particular value, like a constant. Here's our last part. X squared plus y squared plus z squared is equal to 2 inside the square root. Square both sides, and you can see that we've got a sphere, we've got a radius of 2, and our center would be 0, 0, 0. So that's where a level surface can help us graph into the 4th dimension, or at least begin to imagine what such a function could look like.